The last 2 years, 2023 and 24, have meant several milestones for India's space ambitions and for the Indian Space Research Organisation. Starting with the Chandrayaan-3 lunar mission in July 2023,
चंद्रमा के उस दक्षिणी ध्रुव पर पहुंचा है जहां आज तक दुनिया का कोई भी देश नहीं पहुंच सका.
the Aditya L1 solar mission in September 2023, several tests and preparations in the run-up to the super-ambitious Gaganyaan human spaceflight program,
designates को wings प्रदान करे.
a new space policy paving the way for private sector participation, approval for the Chandrayaan-4 in 2024, the launch of 2 satellites with the European Space Agency this year, and finally, on December 30th, 2024, the Space Docking Experiment or SpadeX. Now, this latest one, which involves 2 spacecraft connecting in orbit, is critical to other bigger endeavors such as space station operations, satellite servicing, and even interplanetary travel. So what happened on December 30th? 2 satellites named Chaser and Target were launched aboard a Polar Satellite Launch Vehicle or PSLV. The 2 satellites, weighing 220 kilos each, were launched into a 470-kilometer circular orbit. On ground, think of it as the distance between Delhi to Amritsar. But in terms of height, think 53 times higher than Mount Everest. Now, these satellites are equipped with advanced imaging systems and radiation monitoring devices, providing critical data for future space experiments, including human space flight. Now, the docking maneuver is scheduled for January 7th, 2025. What is this maneuver? Think of a dance between 2 satellites high up in space, like a waltz, and then a hug. Upon successful docking, the mission will test power transfer between the satellites, which is a crucial capability for in-space robotics and composite spacecraft operations. Most importantly, achieving successful docking will position India among an elite group of nations, including the US, Russia, and China, that have demonstrated this capability. This accomplishment is pivotal for future missions too, including the Gaganyaan mission that I spoke about, which has an uncrewed test flight in 2025, and of course the Chandrayaan-4, in which a spacecraft will land on the moon, collect samples, and return them to Earth. Also likely this year is the launch of the Nisar mission, a collaboration between ISRO and NASA. It is designed to provide unprecedented insights into the Earth's ecosystems, surface changes, and natural hazards. That, tons of other initiatives, and of course increased participation from private players will make 2025 a landmark year for India's space ambitions. We discussed that and a lot more in this episode. Listen on, it's Friday the 3rd of January. I'm your host Anirban Chaudhary, and this is the Morning Brief. My guest today is Chetan Kumar, who has been tracking space for more than a decade at the Times of India.
See, for any spacefaring nation, there are milestones that take you forward and allow you to sort of make that leap and grow. And India has had several years with milestones in the past, to begin with the sounding rockets, for example, identification of a launch site and construction of a launch pad, then building of the rockets. But why I thought 2025 will be the most decisive year yet is because of what the future holds, in the sense that all of us would have read grand and ambitious plans announced by both ISRO and approved by the union government in the last few months. So
Yes,
why
sir.
I called this the most decisive year that the space program has seen as yet is because of a lot of activities that are lined up for this year, which will have a direct bearing on the timelines and development of some of these big projects. So, in some sense, ISRO's long test innings is poised and to face, let's call 2025 a super over that will have a great impact on its scorecard. And to list out five things, Anirban, that I think would make this year an important year for ISRO and the space program in general is the two Gaganyaan tests, at least two, that ISRO is planning. One will be an abort test using a test vehicle, the other uncrewed mission, the first of the three that ISRO will have to carry out before eventually trying to send humans to space. Those two are important. ISRO will launch a joint satellite with NASA called NISAR, which will study the Earth and give us clues about how Earth's environment is changing, and hopefully we'll understand climate change better. ISRO will also test the space docking thing. Two satellites have already been launched in the last week of December, and the docking of those two satellites will happen in a few days to come. So that is a crucial mission because that would be important for India to return to moon with Chandrayaan 4 and also the space station mission. Aside from this, ISRO will be launching its 100th launch mission. So that is an important milestone that ISRO is looking at. And then you'll have the private sector, which has lined up a host of activities from space situational awareness to Earth observation and green propulsion. There's quite a bit the private sector is also going to do.
Let's talk about the most imminent one, which is the docking experiment that's about to happen on January 7th. How critical will it be for ISRO's future missions? And more importantly, how does it position India in the global space community?
ISRO has ambitious projects listed for the future for the next decade and a half, which includes building of its own space station, sending a mission back to moon, and this time hoping to bring back some samples from there. And also, Gaganyaan is no more a one-time kind of a mission. So for all of these missions, docking becomes an important technology. And globally, given the fact that only the US, China, and Russia boast of this technology, India will be entering an elite club of nations, just as it did with moon landing. But this technology will be crucial in the sense that aside from the big projects we're talking about, like if you want to construct a space station, you will need this technology. But there are also some other uses of this technology. For instance, if you want to carry out repairs on your satellites are expensive, things. And once their life is over, they more or less disintegrate and you let them rot and fly around in space, become debris. But increasingly in the future, when we're looking at sustainable space exploration, you will want to have, in-service repairs of satellites, like it happens with the space station, for example. The countries, including ISRO and some private sector guys, are also looking at having, satellites that could help refuel, like, mobile petrol bunks in space, for instance, where a satellite nearing the end of its life will go and fill fuel again and then recharge itself and continue to operate for a little longer, provided the payload's health is all right. For all of this, docking technology will be crucial. But as of now, India is taking the first step with the SpaceX mission, which was launched on December 30th. And Jan 7th is the nominal date. As in, when ISRO says nominal, they mean if all things go exactly as planned, Jan 7th, this should happen. But there's a window in which they want to achieve this. It could even be Jan 10th, but Jan 7th is the announced official date. So it is a very critical technology to possess. So I think that is in the right direction given the kind of projects ISRO wants to implement in the next decade and a half.
Right. What challenges could be there in this, in achieving automated docking, and how is ISRO prepared for this high stakes? It's clearly a high stakes experiment.
No, it is. See, everything is challenging because you've never done this. You have no reference point to the systems you've built. And like with everything that operates in space, no amount of simulation on ground can really give you 100% confidence that this is going to work. So ISRO has developed a lot of sensors to enable the two satellites to do this. One of the biggest challenges would be the size of the satellite itself, because these are two small satellites, as in 220 kilos each. So to have the kind of precision movement of these satellites, to control them and to make them behave exactly the way you want, in itself is a challenge. So it is going to be quite challenging. We'll only know on Jan 7th or a little later about how ISRO went about achieving this and what some of the challenges that gave them, an edge of the seat kind of a concern. We'll
Right.
know that once the operation is actually carried out.
Okay. Chetan, what about, ISRO's usual trademark, legendary actually, frugal engineering that has been part of so many of its projects and has also been sort of really, saluted by the world, if I may use that word. Is that central to this docking technology as well?
The low cost affordability of ISRO is often taken out of context, and there are some really bad comparisons of ISRO missions with movies or one ISRO mission with another country's mission. But it's all very unfair because there are multiple things at play. One, there is no publicly available document or data set that gives you the exact cost of any of India's space program missions. As in, there are budgets that are announced for a certain mission, and eventually there are announcements made about, okay, this is how much we ended up spending. For example, the Mars mission was to happen in about 450 crores, and ISRO ended up saving a few crores even in that when the final announcement came. But what you don't know is there's no usually a breakup available on what is the cost of the rocket, how many are you counting the man hours of the project team that was there, are you looking at raw materials, are raw materials specifically procured for these missions? There's no clarity on this. So I'm not saying India is lying about its cost. I'm saying how this is calculated, nobody knows, but the final figures are usually given. So why India's space mission is affordable is also because we had discussed this in Times of India in one of our copies when Chandrayaan 3 happened. So how ISRO uses, some of the models it follows, some of the tests that it has designed, and the modular concept that ISRO uses in going about doing a project is what makes it affordable. As in, how do you conduct tests? Because a lot of the cost in any of the mission happens during testing phase and development and design phase. So ISRO is able to minimize a lot of that. And of course, human resource, which is a big part of any mission, is a lot more cheaper in India compared to, let's say, a France or Germany or even the United States. Yes, this is also an affordable technology, indigenous technology. I don't think India has spent as much as some of the other countries did. But you should also understand that some of the other countries were making it in the 50s and 60s when going to space was a lot more expensive than it is now because the kind of tests, the kind of computers that existed. So building things, rebuilding things, you didn't have additive manufacturing, you didn't have 3D printing. So a lot of costs have also come down because of that. But India is still a lot more frugal that way. And ISRO, I think, will continue that with all its missions. It's just the way it's built.
Chetan, you mentioned lunar mission. So let's come to Chandrayaan 4. That is being mentioned as a potential beneficiary of the docking technology. Why don't you tell me a little bit about that? And how could this capability enhance India's lunar exploration goals?
It's fairly simple. So far, what India has managed to do with the moon is in 2008, it sent an orbiter, that is a satellite that goes around the moon. Using its instruments, it studies the moon remotely. And with Chandrayaan 2, the idea was to land something on moon. It didn't happen. ISRO couldn't manage a soft landing, which was achieved later, a few years later, with Chandrayaan 3. So now that the landing has happened, India now hopes that next step should be to land there, bring some samples of rocks and soil, and bring it back to Earth. So with Vikram, the lander on Chandrayaan 3, Vikram is now lying on moon. But with the next mission, you need something that will come back, reattach itself to an orbiter or to a spacecraft that's going around the moon, and then that will be deorbited and brought back to the moon. So this reattaching bit cannot happen without the docking technology, which is what India is trying to test with SpaceX. It will need a lot of improvements. It will need more redundancies because what you do on low Earth orbit is not even remotely close to what you might have to do around the moon because the environment is different, how moon behaves is different. So it is a crucial thing that without docking you can't bring anything back. You can always borrow it or get it from another country that owns it, but I don't think they so easily pass on this technology, which is why India is building its own.
Understood. Okay, let's go over to some of the other significant missions that are being planned in 2025. Gaganyaan, the uncrewed test flight. The ultimate ambition is, of course, the human space flight. How do we see this happening in 2025? And at this stage, how do you see it when compared to other nations' space programs at, of course, similar stages?
See, you would have read and watched it in movies or documentaries how other countries went about sending humans. There was both the USSR and United States, the pioneers of sending things first and then humans to space. Both of them had animals going into space first. India has skipped that stage because now there's enough data globally available on how humans behave in space. But you will have to test all other systems, starting from the rocket to the crew module inside which the astronauts will be seated, the orbital module, include the crew module and service module that supports the astronauts, as in how is oxygen generated, how is your waste disposed, all of those things are what the service module, as the name would suggest. It is there to service the astronauts and the crew module. How that operates, what is the environmental control and life support system, how can that be bettered. So all of these systems will need to be tested before you get humans to use it and put them in a crew module with all of these and send. So ISRO has been building these technologies for several years now, and now it has reached a stage where a lot of these technologies have come to a stage where it's in the engineering models have been completed and you can actually send something to space. So what ISRO is hoping to achieve this year is two things. One, an abort test, and it's most likely going to be a paired abort test. So this is to test a scenario where in case you will have to get the astronauts to safety during launch, and if the exigency happens while the rocket is still on the launch pad, how do you abort and take them away safely? And most importantly, in the Gaganyaan program, the uncrewed mission is being planned for this year. It could happen as early as in the next 8 to 10 weeks, if not earlier. So in that, ISRO is planning to test the environment control and life support system, not the whole system, but parts of it. It will also test the crew module, its ability to withstand, entering space, re-entering the orbit, and then all of its other mechanisms of recovery from the sea once the crew module lands in, let's say, Bay of Bengal. So it's quite exciting. And without these tests, ISRO can't move ahead towards sending humans.
Right, right. The other one that I want to talk about is the NISAR mission, which is quite a high-profile collaboration of ISRO with NASA. Talk to me about it. Where is it right now, and what implications does it have for future international collaborations? Most importantly,
So one major takeaway from NISAR is ISRO and NASA have been partnering for several decades. There was a bit of a rough time post the Pokhran 2 sanctions imposed by the US, and but collaboration has always been there. India has been collaborating with NASA, it has been collaborating with the French Space Agency, the European Space Agency, the Russians, of course, but the French and the Russians have been more of a all-weather ally so far as the space program is concerned. And with NASA, it's been on and off, although scientist to scientist kind of collaboration where governments are not involved has continued through the decades of Indian space program. But what NISAR represents is that finally now NASA and India will be working shoulder to shoulder. It's not a, okay, I'm the big brother, let's help you launch something or let's help you develop this technology kind of a relationship.
right?
Here, NISAR is a dual radar satellite. It has radars in two frequencies. India is building one, NASA will be building one. And the launch is taking place from India, which means an Indian rocket is being used. The satellite itself is a fantastic satellite, at least going by what we've been given to understand. It will help us understand, humans understand how Earth is changing much better than we've known earlier. It will map the Earth's surface and change over time. NISAR is only the first step in what could become a series of satellites in this class and category, which means at least beginning from now, you will know how Earth is changing over the next few years. The fact that this could map the entire Earth in just 12 days is also fascinating. So we'll have new data on sea level rising, on how crops and croplands tracking changes there, agriculture. You can measure icebergs and what is happening with the glaciers. You can look at volcanic eruptions. You can keep listing the kind of impact Nisar is going to have, and
Mhm.
it's also carries another distinction. It's going to be the most expensive satellite humans have launched till date. So that is that with Nisar. I think two major takeaways: one, we'll understand Earth better once this satellite is launched, and two, is now rubbing shoulder to shoulder with the big boys in the big boys club.
Now, before we end, we can't have a discussion on India's space mission and India's space industry without a word on the private sector. So, how do you see that going forward? And if you could give me a few examples.
Now, I think 2025 will also be exciting for the private sector. We've seen some experimental instruments, including that by PureSight, Manastu, Bellatrix, and a few others. One firm from Ahmedabad, I forget the name immediately, and a few others that have sent as part of the Poem platform that launched on December 30th. But there are also other important things that are expected to happen this year. A Bangalore-based firm, Digantara, is expected to launch a satellite. Agnikul, the Chennai-based rocket building company, is expected to announce a few milestone achievements. Skyroot is expected to, perform a few more tests before going into the next level of suborbital testing that they will have to do. And from ISRO and the Department of Space side, they're looking at giving out the SSLV to private sector, transfer the technology and allow the private sector to build it. So that is another exciting thing that will happen. In space is trying to look at public-private partnership for a constellation of Earth observation satellites. So a lot of companies, as either as consortium or consortia or as individual companies, will be participating in these projects. These are going to be a multi-crore kind of projects, and NCIL is working on quite a few commercial things. So overall, the private participation and private sector this year is poised for some exciting developments. And given the nature of the business, a lot of these founders are keeping things close to their chest, as they should. It
Mhm.
certainly merits a more detailed discussion, although
Right.
there's a really long way for the private sector to go.
Thank you, Chetan, so much. Those were some brilliant insights. Thank you so much for joining us.
Thank you, Anirban, for having me. It's always a pleasure talking with the Morning Brief.
Well, all I can say in conclusion is watch this space. That's it for today. You were listening to this episode on the Morning Brief. It was produced by Vinay Joshi and sound designed by Amrit Reggie. The Morning Brief drops every Tuesday, Thursday, and Friday, wherever you get your podcasts. Thanks and have a good weekend. All clips used in this episode belong to their respective owners. Credits are mentioned in the description.